So, okay, here's my pump. We arrived at the job site. I put the panel on test, and I bypassed the audibles. I've turned the fire pump off, and I'm just assessing the situation here. Both the suctions are open, running through a backflow. I've operated every single one of these valves already and broken up the internal stuff that might be clinging on to the pipes. And with my first startup, I will not try to get numbers. I'm just gonna drain all that nasty shit out, but we'll get to that point in a little bit. To prep yourself for some of this stuff, number one is identifying where your discharge shutoff is going to be and where your test header valve is going to be. In this case, suction side always has an OSY. That's by code, install code, NFPA 13. There's very seldomly ones that have a butterfly. That's wrong. It must be OSMY. So another way, a good way to tell is the arrow is going to be spinning upwards. Upwards is in the direction of clockwise. So clockwise is going to be your discharge. It's always coming out clockwise. It's a good way to tell. You'll always have a discharge check. It's another good way to tell. Check valve on the discharge side. Also, you'll have an eccentric reducer. That's your eccentric reducer right there. That stops turbulence and velocity on the discharge portion of your water flow. It's always going to be there. So with those 3 or 4 things that I just mentioned, this is designated our discharge side, and it also feeds the rest of the building. That's how you can tell discharges as well. So there's a 5th. So I've identified my test header as the normally shut valve. It's always going to be normally closed. The valve that's right after that here, this is my discharge. They've also labeled it for me. So I'm going to go ahead and close discharge. Why? Because we don't want pressure running into those risers as I'm forcing out so much. Will it damage it? Not necessarily. I could always start the pump if I didn't have a discharge with like these valves closed, or scratch that. You could throttle this open if your test header valve is after your discharge. Sometimes it's like that. So if your test header valve is after discharge, start your pump, slowly open that to introduce the higher pressure into the system, and then you can throttle a test header valve. Just do so carefully. Anyway, so that's closed. I'm going to acknowledge. Shut up. And I'm going to get a couple more pieces of information. The on-off for the jockey pump over here controller, and then the on-off for the normal controller. So we obviously don't have power because I turned it off, but let's go ahead and turn her on. And there's no loss of pressure, so the demand won't be signaling, the demand pressure won't be signaling the fire pump to start. It's only a certain set PSI this thing starts and stops. Mainly all these controllers are manual stop. Some of them are in jurisdictions are run on a 10-minute timer. This one appears to be a 10-minute timer, and the on pressure is 150 and the off pressure is 160. But what if this wasn't there? We'll go into the menu and you'll go into the settings, and then boom, right when you click into the settings, the cut in and cut out pressures are going to be right there. It's kind of the same for all Tornatec, Firetrol. A lot of the controllers are set up with easy menu functions. So we're also going to go over the jockey and record the on-off on that. These are the things the report's going to ask for. How do you figure this one? It's on-off right here at 160, 170. They're nice enough to do that. But how can you tell? You just push up and it displays on-off right there. Okay. Some of the other controllers you'll have to kind of go through settings and figure that out as well, but they should be posted. I like sharpieing on the corners of the controllers on off, just for my future use. Okay, so but for the sake of this next part, I'm going to be checking the coupling alignment, and I'm going to be placing a reflective piece of tape on the drive shaft right here, so I can measure and read the RPMs from my tool. So let's go ahead and give this a break. I'll come back and show you how to do both of those. Okay, so now we're back in the car, and I took a picture of the calc plate that's on that pump in there, and I'm going to be doing calculations for what am I going to be flowing on my target pitot reading for each nozzle. So I'm on a 1500 GPM pump, and how can I tell? Because what it's always posted on this calc plate are mostly what you're looking for are thresholds, so, and rated PSI. So your rating on this 1500 GPM pump should be a net PSI, G as in gallons, of 95. So 95 PSI, net PSI at 100 or at 1500 GPM, and it shall have 1775 RPM. So there's some other information here like max suction. That's exactly what it means. That's the max suction on the pump of the feed. So coming from the city, okay, we're never going to reach that. It's 146, or yeah, 148. So next is max PSIG. So that's the max PSI, net PSI that this pump ever wants to see. And what is net PSI? It's suction minus discharge equals net or rating. Get a different pen. Or your rated PSI. Well, net PSI. So your suction minus discharge at flowing for your 1500 GPM, and I'll show you in a second how we're going to do that, should be 95 PSI. That's the plus or minus 5% of that number will pass or fail us in NFPA's requirements. So stick with me. So we have a 1500 GPM pump, and I want to flow 4 nozzles. That's what I've set up over here. So how do I figure out what number to reach on each 4 nozzles? So we'll do some math here. So 1500 divided by 4 is what? Let's do that real quick. So get my Face ID in there. So 1500 divided by 4 is 375. So out of each nozzle, I should be flowing 375 GPM to get my 1500 GPM. Okay, that's how you want to do it. So now we look at the chart. The chart is going to tell us what number we need to flow at. I'm not using a hose monster today. I'm going open atmosphere. So 375 on this list is somewhere between 11 and 12. So I'm going to flow 4 hoses at 11.5 to get 375 out of each hose. So 4 hoses at, what I say, 11.5 on pitot-less nozzles. Okay, that when I flow this and I get this target number on my pitot reading, I look at my suction gauge and my discharge gauge, and I subtract the both, and that will hopefully get me 95 plus. It's okay if it's 5% takeout of 95 though, because I'd still pass. So that's my math on a 1500 GPM flowing out of 4 pitot-less nozzles, the grooved type. This is not the threaded, grooved type. You're gonna have to look on your chart for the threaded readings. So it's gonna be somewhere around 4 at They differ. Like if I wanted to run 6 hoses, I would do 250 each hose at 6 to reach 1500 GPM. I've already done those numbers. And then when you go for 150%, it's a different calculation, obviously, because you have to do 2250 divided by 6. See how the math is pretty simple when you start looking at it like this? So what's now that's for 11.5 time at 4 hoses is my 100% rating for a 1500 GPM pump. Open atmosphere. Differs, always differs. Okay, so now let's do the math on flowing 150% for this pump. What's 150% of 1500? It's 2250 GPM. Always will be, every single day. Okay, now you divide that by 4, and what do you get? Okay, 625. So 625 on my list. Oh, that was 2500, sorry. 2250 divided by 4, 562. So 562 on my list is going to bring me somewhere closer to 26, and in between 26 and 27, so I'll go 26.2 on pitot-less nozzles. Okay, so now there's also some more information on this calc plate that you can use at 150% rating. See, that's max PSIG, but you go over here is 1.5 cap PSIG. So I looked that up, and that's the specific discharge pressure the pump is engineered to deliver when it's operating at 150% of its rated flow capacity. So that means at 150%, I can't have the max PSIG on when I'm flowing. Now that's suction minus discharge, should be 83 PSI. That's my rating at 150%. So at 2250 GPM net, that's my max. That's 150% rating. Okay. But so I'm on an electric pump today. And not only do we have to record suction and discharge to get our net PSI when we flow at each target, we also have to get volts and amps. So this is what I do. This is my notes for this place. So I have my jockey on off, or my fire pump on off, jockey on off. I'll show you how to get those later. At churn 0%, it's suction's 40, discharge is 162 RPM. Yes, we have to get that too. Show you how to do that as well. Volts, amps. Okay, now I've drawn my graph here. So 100%, not my graph, but my number sheet. At 95 psi, flowing 4 nozzles at 11.75 pitot reading will give me 1500 GPM. Just ignore this part. Suction, discharge, RPM, volts, amps for each reading, 150%. There's my 26.2. Suction, discharge, RPM, volts, amps. So now I'm going to go back in, or kind of show you how I connect all my equipment up at the test header, and we'll flow test. So here we are. I've connected 4 of my pitot-less nozzles that are grooved. It's hooked up for open atmosphere. We're gonna get a little bit of rock coming out, but it's okay. I got my broom and my shovel. I'll clean up what I can. It's so convenient, and the way my truck is set up, I choose not to run hoses right now. So I connect my rainbow hoses, and it's the long side first, where there's not, it's not bound by the black stuff. The shorter, unbound part of the rainbow hoses will go back to my test header, and I'll be throttling with the gauges right here, reading my PSI coming from my nozzles. So what I've done is open up all of them already, because I'm not going to open these up during the whole or close them down during the whole test. They all will remain open. So my valves are open, my quick fittings are fit, nice and tight, and you see how I'm draping it kind of over away from the blast of draping the rainbow hoses over away from the blast so they don't blow off. So we'll go back into the pump room and I'll begin that process. Here's one thing that's pretty important. You got to get your tools right. What are you going to bring to the job site? What are you going to have on you? I tend to go overkill, but these are the basic needs when we're doing the fire pump. The equipment you need, aside from the hose monster kit that we talked about. So I'm going to need some gloves, some baling wire, possibly a flashlight, a wire scraper possibly. You're definitely going to need a tachometer. This one is pretty cheap. It's $80 on Amazon. I suggest you spend more money because the readings on this are pretty hard to get. It comes with the reflective tape that I've cut into squares, and I'll show you what we're going to do with that later. I have a magnetic level right here, and I have a 1/2 inch open end, closed end, and I have a 7/8 wrench. So we'll get into what we're going to be using those tools for later. Okay, turns out I didn't need my 1/2 inch open end wrench because these are pretty easy to take off. So I've taken both sides out, and I'm just going to go ahead and lift up on this right here. Boom. Exposing drive shaft coupling. So next, let's go to a little test I can do is level the pump. And it's off a bit. So what do? I'll write that up. I have a leveling company that comes out, and they shim the pump. As you can see, there's a couple shims on there. Looks like they need to lift this front end up a bit, but we have people that do that are certified. So this pump fails coupling alignment. It is not level. So we'll get after that later. But what I've done is cleaned with my wire brush my drive shaft here and the packing gland a little bit in order for me to stick my reflective tape there. So that reflective tape is going to be read with the tachometer and give us our RPM when we run the pump for 0%, 100%, 150%. So let's go ahead and talk about a little bit further more of the steps. I've got the 7/8 wrench here that I will use the closed end only ever to adjust my packing. As the code wants, it's 1 drop every 3 seconds. Well, we're about there, and I'll show you why I don't really like that NFPA book stat requirement, because you just want that packing to be wet and not over profusely flowing ever. And we only want to tighten that or loosen that when the pump is running, never while the pump is off. So it's really hard to dial these things down. Sparingly read that code and exercise your right to be a tech. So right now we are done with our prep work, other than we're going to be removing these air gauges and putting our oil fill gauges on discharge and suction side to get nice smooth readings, and come back to you guys when we start this thing back up, and we'll talk about the circulation relief valve. Okay, I wanted to talk about these circulation relief valves before I open the pump up. They're super important to be flowing when this pump is ran, because what it's doing is removing the excess heat that builds up inside the pump and excess pressure. So we don't get too much pressure going through that pump and cause things to overheat and things to be overworn, because we want this thing to work 100% when we get the pump running. So I'll show you how to adjust these things and play with them. First off, this is factory settings, so I'm just going to mark off where they've set that. Get a good marker, mark your thread there really deep. Okay, so that way when we back out that nut and I start playing around with it, we figure out how we can open and close it and adjust it to our will. So yep, I'm going to need a bigger wrench here, so give me a minute. So I wanted to take a minute and talk about the circulation relief valve. Actually, this is what it looks like when you open the cap. You have a nut there holding it back from adjusting itself while it's running and falling out of calibration, but I went ahead and used my marker to mark the setting that it is at right now so I can go back to it. But I'll show you how to adjust these things. This is a 9/16 wrench to loosen this nut, and we're just going to back it up because I'm going to open and close this thing and see if we can get it exercised without the pump running and setting it back to its normal setting. So I also have a 3/8 right here. We're going to go ahead and probably use this end to close all the way. And to me, it looks like righty-tighty is increasing its pressure to kick on. Okay, that's a good exercise right there. And we're going to go back the other way. Until it starts, and then we will back it right out. Because what it's seeing is, what's the pressure at right now? 50, 60 psi. So anything higher than 60 psi, this pump runs, this thing opens. That's the theory. So let me open it up, see if we can freak this thing out. And run. Okay. That's pretty crazy. Almost all the way out. Okay, yeah, like I said, just had to keep on going a little bit more, and there's my on, or open. So I'm gonna go ahead and close it now until that stops. And there it is. Test stopped. But that's how you pretty much adjust these things. Let's see where my mark is. So there is a little bit of a play with these things going on and off the way they're set, because when I got here, it was all the way at that black mark, kind of like right here. So we'll go back, put it to what it was, make sure it works right, and if it doesn't, we'll just adjust it. These are super simple to work on. I've actually been to a pump where the engineer didn't like that it was flowing when the pump ran, so he switched this whole thing around. So, all right, I'm gonna put that back to normal, start the pump, and see if it runs normally. So now we're gonna go through the various start and stops of this thing. You're gonna do auto PSI drop. I'm gonna do the power button, and I'm gonna see if the emergency start works, if there's a generator on site. So we'll go ahead and do all three of those, and starting with the first one on at 150. Now, circulation relief valve is flowing. Number one, it has to flow. If it's not, I'm turning off the pump and I'm not doing the test. Good to go. Okay, let's go ahead and see if stop button works. All right, stop button worked. Now, see how the pressure is below 150? Because I have my discharge valve shut. So when I let go of this button, it's going to start on demand. And there it goes again. So let's go ahead and just turn this off. That works. And let's balance the pressure in the system. So it's not on demand anymore. Just crack it open and close. And you'll see my discharge, my jockey, or my controller gauge is now above 150. So we're going to go ahead and turn it back on. And the reason why that started again is because the sensing line is before the discharge check or discharge shutoff. Because since I dropped that PSI from there, that's why it started. So we just balanced that pressure out. We're going to go ahead with the power button. This should run it. Cool. Pressure did not drop, so I could shut it off with the off button. Okay. System back to normal. Now let's go ahead and emergency start. Awesome. So no generator, just operates on emergency start. Soft starter fault. It's because it does not like to be start in emergency mode, but it's just something that we have to check. So now I've prepped the pump run as much as I could. I even used my baling wire to clean out that hole down there that feeds this drain so this doesn't overflow if it flows a little bit too much water. And we're going to go ahead and start our churn and our 10-minute test and our flow test. So I'll do it again. Pressure dropping. And we're flowing. This will stop at some point. When I go for my 100% and my 150%, there's going to be too much demand, and all that water that should be coming out here, cooling the pump, is now coming out of the nozzles that we hooked up, out of the test header. So I have my gauge right here hooked up with red, white, blue, and green. Everything is open. I'm going to leave them open for the beginning part of the test until solid streams of water come out of this end. So once a solid stream, no more air bubbles, I'm going to close this and start getting my readings. I've marked my gauge for 11.75 for my 100% and 26.2 for my 150%. So there's no guessing. Once I hit that target mark, I take my suction, discharge, RPM, my volts and amps. Volts, amps on leg 1, leg 2, and leg 3. And I'll continue with the 100% and 150%, and then we're done. As maybe you can see, that's pretty dirty water coming out, so I'm just allowing that to escape before I do anything more. Man, that's dirty. 125, 36, 477, 137, 125, 36, 38. We're shutting it down. Nice and slow. Nice and slow. Cool. And that's it. Let's do some math. 477, 111, 1788. Whew. So, our 100% run was 45 suction, 151 discharge. -151 minus 45. Boom. We passed. So, well passed by 10 psi. So, we'll run our numbers when we're done. I can shut it down because NFPA just wants 100%, but manufacturer wants 150%. So, we passed. And I'm going to go ahead and wrap this up. Shut it down. After its 10 minutes is done. Got one more minute. Okay, I wanted to go over a few more things. When do you run the pump and frequently asked questions? So, when do you run the pump and stop it for any reason? Okay. For electric, there's a couple things. And some of it goes towards all pumps, okay? It's unusual sounds or vibrations. If that coupling is off enough, this thing won't run right. You will know right away, okay? That's one. Two, your suction PSI is below 25, 30 at any rate, even when you're flowing for 100%, 150%. I don't like to run it with that low of PSI. You could cause cavitation in the pump or behind the pump, so I stay away from that. I also look for anything leaking, piping, especially the discharge test header area. If you have any leaks, I won't, leaking from VIX or corroded VIX on this line, I will not run it. It's just too much. Also, when you're running it, and if your suction minus your discharge gauges read less than 40 psi, I was taught at Oklahoma State University to stop the test. Typically, it'll always result into not enough demand pressure. The city could bump up their pressure. You can request that for your local area and jurisdiction. The city takes care of that suction pressure too, if it's fed from the city. So it's different when you're running a suction tank. You can get into the negative numbers on suction side with a tank, and that's okay. But rule of thumb is if your net is below 40 psi, terminate. You can cavitate the pump. Another one is power issues with the electric controllers. Sometimes you'll get that. You might be getting low oil on a diesel. I won't run it if it's low oil, depending on how low it is, right? You want to get the right amount of coolant, right amount of oil, right amount of electrolytes in your diesel batteries, but today we're just talking about electric stuff and general shutdown requirements for me. Other than that, the pump not being aligned properly and not level, I'm going to make a note of it, reach out to the customer. This place is probably under warranty, and get that fixed pretty quickly. It's a empty shell of a building right now, so that'll be an easy correction for them. Other than that, my results did pass. My packing is not leaking profusely. I went ahead and replaced the gauges. Always put Teflon back on your the gauges that were here in the first place. Covered that thing up right there. It's a little plug that goes in. They don't have one for the outboard side of the packing. This is inboard. That's outboard. In reference to the driver, inboard, outboard. My bearing boxes did not overheat. They did not need grease. That's pretty much it. I'm gonna wrap up this, tag it, open my discharge valve, restore my fire alarm panel, and we are good to go. So I'm just gonna go over some of the report stuff here. This is how Siemens does it. It is an electric pump, centrifugal. The other option is turbine. It is not a turbine. Turbines are typically up and down, vertical. This is a horizontal. There's your option for turbines right there, but it's a horizontal. Patterson, it's approved because it has a calc plate. If it doesn't have a calc plate, odds are it's not approved. All this information, the 1500 GPM. This was my net PSI at churn, my net PSI at 100, my net PSI at 150. It says pump head PSI, but they want that. That's how they ask for it in my form. It's rated RPM is 1775. City fed from 8-inch, no tank. Here's the driver information all the way down, the horsepower, everything like that. It's a 3-phase. It's on the calc plate as well, on your driver, your electrical motor. All this stuff is Tornatec controller. The on, there's the on. The off that I showed you we got earlier. Okay, jockey was tested. There's the jockey on off. Jockey pump passed. Fire pump passed. Fire pump controller overall condition passed. Gauge is good. Pressure relief there is not one here. Packing and drain was good. 3 seconds to run full speed. 10 minutes run time. There's my test volts, amps, RPM, suction, discharge, and I just go through. That's a 0 flow because there's no GPM. Volts, amps, RPM, suction, discharge. The rated PSI, I know that because that's 95 on my calc plate. We flowed at 106 being our net PSI at 100%, so we well above 95. 1500 GPM was that flow on test number 2. Test number 3 is 150%, and just 2250 GPM right there. And then I'm just going to go ahead and save all this because it's going to do its algorithm and plug it into a chart for me after I print this report. But let's go through some of the questions on the fire pump inspection portion. The heat is higher than 40 degrees in there. Intake louvers are operating. There is one in there that opens when the pump is running, or it's above, I think, 70 degrees. Pump suction, discharge valves are open. No piping or hoses leaks. Fire pump leaking 1 drop per second, yes. Or 1 drop of water per second it seals. Suction line pressure is normal. System was normal. There is no suction reservoir. This is all controller, transfer, isolating, reverse phase. These are if I would have a transfer switch for a generator. So we don't have any of that here, but the power is illuminated on. No phase rotation. There is no, nope. This is all diesel questions right here. Oil and vertical motor site. That's for vertical turbine motors. No tank. Auto, batteries, charging, pilot lights for batteries. All alarm pilot lights are off. Yes, they are. We didn't record any engine time for meter because it's electric. Oil level, crankcase, cooling water, electrolyte levels, battery terminals. This is a lot of diesel questions that I can get into later. But I did compare transducer pressure to discharge pressure. And then I did inspect the coupling alignment, which there will be notes about that. Testing. Simple questioning. Yes, we operated for 10. We did. We adjusted the glands if necessary. We did check for unusual noise or vibration. The packing boxes or bearings, typically that's 180 degrees. You don't want those bearing or casings to go over about 180 degrees. Each pump is different. You can look it up for Patterson, what they recommend. So on and so forth. If there's any other model, just Google it. We didn't check oil pressure gauges. There is no heat exchanger here. I wish they asked about circulation relief valves on pump reports, but they really don't. We didn't check any of this. Steam trap, no steam. Check for controller alarms, we did, and it was cleared. And we did hose stream. Automatic transfer test simulated. See, we did not do that. Nope. We operated all alarm conditions and simulated, and that's it. Safe. We are done. So there's all these groups too. Gotta figure out what these are for. But anyway, that's how you fill my reports out.